Okay, today we're going to talk about describing location in a distribution. So how to describe a data point within a distribution. So if you have a data set, how do you describe your position or, where you are type of thing. Okay, so that's what we're talking about. So let's go to page, looks like 91. Describing location in the distribution, okay? The very first thing that we're talking about is percentiles, okay? And you've used this before, percentile, all right? I am 50 percentile, 95 percentile, or whatever and all that stuff, okay? So let's look at the definition there, the green box. An individual's percentile is the percent of values in a distribution that are less than the individual's data value, okay? Less than my data value. So in other words, if I stacked all of the data from small all the way up to large, okay? If I am here and I looked back, if I am the 50 percentile, that means that I'm looking back at, not including me, there's 50% of the distribution of the data that I can see. Okay, all right, does that make sense? So what does it mean? So what does 75% mean? Let's say that we stacked all the, went to the, I know we took your class and we put it in from shortest to tallest, and you are the 75th percentile. What does that mean? Anybody? Kat, what does that mean?
Does that mean that you're like in the taller area, like you're like the 75th like air, like the
Yeah. So you're definitely in the taller area, right? Because you're taller than the median, correct? What percentile would be the median?
50th?
Yeah, so 50th percentile or 51st percentile, right? Because if you're the 51st percentile, that means that you're looking at 50% behind you, correct? Does that make sense? So 75th percentile means that if I stood up and I looked back at how many people are in front of me that are shorter than I am, there's going to be what percent?
74% of the students in your class.
75%, because you are the 75th percentile, right? What does it mean to be the 99th percentile?
99% is behind you.
Correct. So 99% of the people are behind you, correct? What does it mean to be the 100th percentile?
You're the tallest.
Nope. Trick
Can't
question.
you not have 100 percentile?
Correct. There is no such thing as 100 percentile, right? Because you can't be in the data set and say that there's 100% behind me, right? So there's no such thing as 100 percentile, all right? The largest would be the 99th percentile, where you are the tallest person and you look behind and you see 99% of the data. Does that make sense? Okay. So it's kind of nitpicky thing, but if you understand that, you understand what the percentile is. Okay. So let's go to, so we talked about the percentile. Let's go and read the example there on page 92. So we have the dot plot of Mr. Tabor's first stats test. A, find the percentile for Jacob, who scored 18 on the test. So if I scored 18 on the test, and there are 25 scores, how many people are behind me? How many people are in front of me? How many people scored less than I did? Looking at the dot plot.
One person.
One person, right? In other words, you are the 1 out of 25th percentile. So you are the 4th percentile, right? Does that make sense? Number 2. Maria's test score was at the 48th percentile of the distribution. Interpret the value in context. So she was a 48th percentile, meaning that if we stack the scores from lowest to highest, there would be 48% of the data that had scored less than she did. Okay. What score did Maria earn? So you would take the dot plot and it was 48, you're 48 percentile, right? So 48 percentile is equal to 25 over what? 12, I guess, 12. So there are 12 people of the 25 that are lower than Martha, was it, or Maria? Maria, which means that Maria was the 13th data point, right? From the low end, if you counted out number 13, that would have been Maria's score, which just happens to be what? Can anyone tell me what that is in this particular question? Can you see that she would be the median score? Can anybody tell me why she's a median score? No, because you're number 13 out of 25, right? You're right in the middle. So you're the median. Okay, moving right along. Cumulative relative frequency graphs. Cumulative relative frequency graphs. So what that is that let's say you had a data set that, okay, so they're giving the, on page 93 on the left, there's an age bracket, okay, and there's a frequency table there, and you have 40 to 44, 45, 50, 55, 60, 49, 54, 59, 64. And there's one more, 65 through 69. And the frequencies go 2, 7, 13, 12, 13, 12, 7, 3, 1. Okay, so this is the frequency of your data set, right? This is your data set right here. Looks like this. Okay. So how many people are there all together? I have 20, 34, 44, 45 people. So I have 45 people all together. Okay. So if I do the percentage wise, does it give this to us? Yes, it does. So it turns out that this is going to be 4.4% and 15.6. So basically it took 13 divided by 45. And if you do that, you get 22. Then you get 34. Oh, no. 15. 28.9. 28.9. After 28.9, we get 26.7. And then we have 15.6, 6.7, 2.2. Okay, so that is the relative frequencies, right? This is the relative frequency. All we did was take the number 7 divided by 45 and convert it into a percentage. That's all we did here. Okay. Now we're going to have a cumulative, so this is a relative frequency. Now we're going to have what is called the cumulative relative frequency. And cumulative meaning you're adding them, Okay, so you're gonna add, so we have 4.4. Next one, you're gonna add these two together to become 20. The next one from 20, you're gonna add the 28.9, you get 48.9. 48.9 plus 26.7. You're gonna get that, and then you add that to that. You're gonna get that, and you add this together. 8.9, and you add that together, you're gonna get 100%. Okay, so you see, because it's cumulative, it gets larger as you go. Okay, because you're adding to this guy to get that, adding to this number to get that, then adding that number to get that, and so on and so forth. So this is what's called the cumulative relative frequency. So it's a cumulative relative frequency. So if I were to go ahead and actually plot this, it's going to plot out like something like that. Okay. So what is the end? What is the very top up here? Can anybody tell me what the very top of numbers there is going to be? What does it have to be? In the end, what percentage am I going to get? I'm going to get 100%, right? Because when I'm adding them all together, I get 100%. I have to get 100%. Okay? All right. How would you describe this distribution? Anybody?
Skewed to the left.
Skewed, if I go like this, it's going to be skewed to the right, wouldn't it? I'd have more data points. I would have more data points on this side, wouldn't I? On the low end, from here to here. On the high end, I have less. So it's going to be skewed to the right. Skewed to the right, okay? Slightly, not that much, but a little bit, okay? A lot of it is in the middle, right? So almost to the point where you could possibly say that it's roughly symmetrical, okay? So let's go to page 93, middle of page 93. There's a green box there. Read that.
Mr. On,
Yeah,
I don't think your graph matches the one in the book. Maybe I'm crazy.
yeah. I just kind of quick handed that one. So yeah, I mean, the book's correct, obviously, right? Not drawn to scale. Does that make sense?
Yes.
Okay. Thank you.
Well, what would that score you on the stats test, Mr. On? You can't
Huh?
get away from that.
So let's go ahead and take a look now at the cumulative. Let's look at the correct cumulative relative frequency graph and see if we can kind of interpret it together. So let's look at the correct one. And the correct one is on, where is it at? It's the bottom left-hand side of page 93. And it looks like, that, okay? A little more smoother, okay? This would be 100%. How would I find the median here? Can anybody tell me how I would find the median? What is the median? It's one right in the middle, right? So if the middle one were to stand up and look behind, how much data would he see? 49%, right? Or 50, right? So in other words, I would go 50 right here and read this, and this would be the median. Anybody see that? If I wanted the 75th percentile, I would go ahead and read off 75 right here. And this guy here would be the 75th percentile, or roughly, right? 71st, so this would be 75%. Can everybody see what I'm doing right here? How that makes sense, how they correspond to each other? Are we good? Okay, so that's that. So that's how you would read and use the cumulative relative frequency graphs. Okay, so now let's consider the fact, let's consider what we talked about earlier. How would a skewed to the left distribution look like in a cumulative relative frequency? So if the distribution was skewed like this, what does that mean? That means that I am adding a lot of the data early, but less over here, right? So the cumulative relative frequency graph is going to look like what? It's going to grow quickly and then taper off at the end, right? So this is the cumulative relative frequency, and this is just the distribution of the data. Okay. If I was skewed to the left, it means I'm not adding much data early, and then later on I add all the data, right? So early I am not adding much data, but then later, I'm at a later stage, it goes like this. Okay, so in other words, the point where you're adding all the data comes back over on the latter part of the distribution. Okay, it would look like that. And if I had something that was roughly symmetrical, it's going to look like, if this is about roughly symmetrical right here, my cumulative relative frequency graph is going to look like that, where it's evenly, most of the data gets added in the middle point, the midpoint right here. It's going to look like that. This is also known as the S curve, okay, the S curve, growth curve, or a regular, for a normally distributed or roughly symmetrical data, okay? All right. So that's that. And that's how you do that. So let's go ahead and look at the example on page 94. Age of US presidents. Use a graph in figure 2.2 to help you answer each question. Figure 2.2, do we have that? And where is it at? Oh, that's the one that we were just talking about. Okay, was Barack Obama, who was the first inaugurated at age 47, unusually young? So we look at 47, we would go back to the cumulative relative frequency graph that we had. And if we look at 47 is going to be about here, and you're going to read off the cumulative relative frequency as about 11%. 11%. So yes, he was unusually young, correct? Oh, so the book says he was fairly young, but not unusually young. Okay. We'll come back to this later on in the book, okay? Where do we cut off? Where is a cutoff point to be unusually young or statistically significantly small or significantly large, okay? We'll discuss that later on, okay? But just keep that in the back of your mind. Okay, I'm not going to disclose that as of yet. B, estimate and interpret the 65th percentile of the distribution. So you would go here and you go 65%, and you would go down and you would read off whatever age that is. Okay. And if you do that, it looks like it is 58. Okay, looks like it's 58. Okay, so that's one way to measure your position in a distribution. Another one is to read what we call the z-score. In other words, if I have a distribution that looks like this, with the median or mean being right here. Okay, let's say that I gave you guys a test. So let's talk about this test that we just took, right? The test that we just took was like 62% was the average right here, okay? And let's say that I did the standard deviation, and the standard deviation was 5, okay? So how would you describe a score of 52? If I had 52%, okay, how would you describe this score in reference to the mean? Okay, in reference to the average. I am how many points away from the average? Can anybody tell me? How far off am I from the mean?
10%.
10%. And how many standard deviations is 10%?
2.
2. So in other words, I am 2 standard deviations below the mean, right? What if I was 67%? So based upon what we just said, how would you describe the 67%? I am
One standard
One.
deviation.
1 standard deviation above the mean, correct? Right? And the way that you would figure out how many standard deviations away you are is that you would take whatever your data point is, right? Whatever your data point X is, and you would subtract from that the average, and you would divide that by the standard deviation, right? That's what we're doing, correct? This is called, and it is notated as such, it is called the Z-score. It's called the Z-score, okay? We call this the Z-score. So if you go to the bottom of page 95, definition, standardized score, otherwise known as the Z-score. It takes your value divided and you subtract the mean and divide it by the standard deviation, just like we did. Okay? That's how you find the Z-score. Okay, so let's look at an example. Let's go flip the page, go to page 96. Let's see where's first test again, find the, so let's say number 23, use figure 2.3 to do that. So find and interpret the score for Jacob. The Jacob had 18, right? He had 18. So I had 18, so he scored 18 on a test that had an average of 35.4, and the standard deviation was 8.77. So this is how you would define the Z-score. So this Z-score is going to be positive or negative. Can anybody tell me?
Negative.
It's going to be negative because the numerator is negative, right? Okay. This is a moment of, we did some math here, finally. Okay, this is our math for the day. We subtracted, okay? That's our math. So we're going to have a negative number here. So a Z-score that is negative means what? I am above or below the mean.
Below.
You're below the mean. The Z-score is positive, that means you're above the mean, correct? Okay, so the Z-score kind of gives us the position also that way, right? Not only how far away are you, but are you lower, or are you higher? Okay, so that's how you find the Z-score. B, Tamika had a standardized score of 0.292. What was her score? So this time, they're not going to give you the score. They want you to figure out the score. And they tell you that the Z-score is that. Okay, so we're going to have to do some more math here. How do I find this? I'm going to find X.
You multiply.
Oh, I have to multiply by 8.77.
Yeah.
And you get X minus 35.4 is equal to 0.292 times 8.77.
And then you add the,
Oh, then I have to add the 35.4. That would be your answer. Okay? All right. And the reason why I'm pointing out that we're doing math, because I told a lot of you that we're not gonna do a whole lot of math. This is about the kind of math you're gonna be doing, okay? All right. So if there are no questions, we're gonna stop right here. And we'll take, let me see.